Lesson 8.3, Multivariable Linear Systems. Multivariable linear systems means we're going to have more than just x and y. Well, for the most part, this lesson will just have three variables, x, y, and z. And we're going to solve them by putting them into row-echelon form. For row-echelon form, the first non-zero term in each equation has a coefficient of 1. All terms under the leading 1 are 0, producing an inverted pyramid shape. And any equations that's all zeros are at the bottom. Something like this. Notice we have 1x, 1y, 1z. That's upside down and kind of makes this upside down triangle. That is row-echelon form. We can put a system of equations into row-echelon form by using the elementary row operations. So, these are the allowed operations. You can interchange two equations, so you can just flip-flop them, trade places. But obviously won't change any values. You can multiply one equation by a non-zero constant, so we're just multiplying both sides of one equation by the same thing. And you can add a multiple of one equation to another equation and replace the latter equation. So you can add two equations and replace one of the equations with the result. All right, so let's solve the system of equations. Well, notice it already has a 1x on the first equation. And so what I want to do is I would like to eliminate the 2x to make it a 0. So I could multiply the first one by -2 and then add it to the second equation. Let's see if we can do that in our heads. -2 times 1x is -2x. Well, is plus 2x is 0. And this is going in the second row. So maybe we'll just write the first row. I'm not changing the first row and I'm not changing the last row. I'm only changing the middle row. So the middle row, -2 times x plus 2x is 0. -2y plus a -y is -3y. And -2 times z is -2z plus 3z is 1z. And -2 times 3 is -6 plus 16 is 10. Now I'd like to make that a 0. So I could multiply my first equation by -1. I want to change the last equation, so the first equation and the second equation are going to stay the same. The third equation becomes -1 times x plus x is 0. -1 times y plus a -2y is -3y. -1 times z plus a -z is -2z. And -1 times 3 plus 1 is -2. All right, so I've now eliminated everything under the first x. We're going to work our way down. We need to get rid of the y in the bottom. So I could do that by multiplying the second equation by a -1. I'm changing the bottom equation, so the first equation and the second equation are going to stay the same. The bottom equation, though, changes. I'll have -1 times -3y plus a -3y is 0. -1 times z plus a -2z is -3z. Negative 1 times 10 plus negative 2 is negative 12. So now I have that inverted pyramid shape. Now I need to make the leading coefficients 1s. So I'll multiply the second row by a negative 1/3 and the third row by a negative 1/3. The top row isn't changing. The second row becomes, I'm multiplying it by a negative third, so negative third times negative 3 is 1. Y. Be negative 1/3 z and negative 10/3. The bottom equation, negative 1/3 times negative 3z is 1z, and negative 1/3 times negative 12 is 4. So look at that. We now know z is 4. So we could plug that into the second equation, and we could find y. So it'll be y minus 4/3 equals negative 10/3. So if I add 4/3, we'll have negative 6/3 or negative 2. And then we could plug both of those into the first equation, which was x plus y plus z equals 3. So x is 1. So our answer is x, y, 2, and z. 1, negative 2, 4. Let's try another. All right. We're starting off, we do have a 1x. So let's get rid of the x's below it. So let's get rid of that 2x first. So I could multiply the first equation by negative 2 to get a negative 2x to go with my positive 2x. I want to change the second equation, so my top equation will stay the same. The bottom equation will stay the same. The middle equation is the one that's changing. Well, if negative 2 times x plus 2x is 0, negative 2 times 2y plus 3y is negative 1y. Negative 2 times negative 7z plus z is 15z. Negative 2 times negative 4 plus 5 is 13. Now let's get rid of that x. We could multiply the first equation by negative 3 and add it to the third one. Top equation won't change. Second equation won't change. I'm just changing the third equation. Negative 3 times x plus 3x is 0. Negative 3 times 2y plus 7y is y. Negative 3 times negative 7z is 21z plus a negative 36z is negative 15z. And negative 3 times negative 4 plus a negative 25 is negative 13. Okay, working our way down. Let's get rid of that y. I could just add the second and third equations to get rid of it, because I have a negative 1y and a positive 1y. Top equation is staying the same. Second equation is staying the same. Bottom equation becomes negative y plus y is 0. 15z and negative 15z is 0. 13 and negative 13 is 0. So notice we got the 0 equals 0. That means there are many solutions. But we don't just say many solutions. We have to actually describe these solutions. So to describe them, we're going to use something convenient, in this case z. We're going to let z equals a. And then we can take my second equation and we could change the z for a and solve for y. So subtract the 15a, divide by a -1, so y is 15a minus 13. So I have an expression for z, I have an expression for y. So now if I take my first equation, I could find x. X plus 2y minus 7z, z is a, is -4. Distribute. Combine like terms. And get everything to the other side. So x would be -23a plus 22. So now our answer is x, y, z. And what this tells us is a could be any number, and if you plug it in, it will give you a point on the solution. So if a was 0, we'd have 22, -13, 0. If a was 1, we'd have -1, 2, 1. And all of those are points on the solution. The solution is, in this case, is a line, and those are all points on that line. Let's try one more here. Well, this is a problem. We only have 2 equations. So that means that we can't have a full solution, because you have to have at least as many equations as variables to get one solution. So this will necessarily be many solutions. But let's still get it in row-echelon form. So let's get rid of this x. So I'll multiply the first row by -4. The top equation is not going to change. I'm changing the second equation. So I'll have -4 times x times 4x is 0. I'll have -4 times -y, which is 4y, plus, and there's no y's there, so we just have a 4y. And I have -4 times 4z plus a -z. I have -4 times 3 plus 0. All right, let's finish getting in row-echelon form. So I'm going to multiply the second equation by 1/4 to make it a 1y. And notice we have this beautiful fraction. Well, since it's many solutions, we're going to let z equal something. But if I let z equal 4a, when I plug it in down here, it's going to cancel out the fraction. That's why it's 4a instead of just a. So then I take that equation, 17/4 z. I'm going to let z be 4a to cancel out the fraction. So y is 17a minus 3. Now if I take my first equation, I can get x. X minus y plus 4z, and z was 4a. Distribute. Combine like terms. oops, that's a 3. Getting ahead of myself. Add the a and subtract the 3, so we get x equals a. So our answer is x, y, z. And again, any number we plug in for a will give us a point on the line which contains all the solutions.